In a chemical reaction, mass cannot be created or destroyed. If we start with a certain amount of matter, we must end with that exact same amount. But often, when we first write out a reaction, the representation is physically impossible. It looks like a scale tipping out of control. Take this equation for iron reacting with water. As written, it suggests we are creating iron and oxygen atoms out of nowhere. This is a skeletal equation. It identifies the substances involved, but it currently breaks the laws of physics. To fix this, we use the hit and trial method, a systematic way to balance the atoms on both sides until the math matches reality. Grab a pen and paper now. Writing this equation down will help you follow each step as we move through the process. This process turns a theoretical chemical description into the precise math required for real-world laboratory work. Step 1 is to establish your boundaries. Draw boxes around every chemical formula in the equation. You must not change anything inside these boxes. We cannot add subscripts or alter the molecules to make the numbers work. We can only add coefficients to the outside. Step 2 is taking inventory. Build a table with 3 columns to compare the left-hand side, the reactants, to the right-hand side, the products. We start by counting the iron atoms. We have 1 on the left, but 3 on the right. Hydrogen is currently even at 2 and 2, but oxygen is heavily imbalanced, with 1 on the reactant side and 4 in the products. This table identifies exactly where the imbalances are. It shows us which elements need our attention first. In step 3, we pick a starting point. A good rule is to target the compound with the most atoms first. Here, that's Fe3O4, specifically focusing on those 4 oxygen atoms. To get 4 oxygens on the left, we place a coefficient of 4 in front of the water molecule. Now our inventory shows that oxygen is balanced at 4 on each side. Step 4 is handling the resulting changes. By putting a 4 in front of the water, we multiplied the hydrogen as well. We now have 8 hydrogen atoms on the left. To balance this, we go to the right side and place a 4 in front of the hydrogen gas. Now the hydrogen count matches at 8 on both sides. Step 5 is the final element, iron. We have 3 atoms in our products, but only 1 in our reactants. We place a coefficient of 3 in front of the iron atom on the left. Every element in our inventory is now perfectly balanced. By focusing on the largest compound and adjusting for each change we made, we have brought the entire system into equilibrium. Step 6 is the final cleanup. Now that the math is correct, we can remove the boxes and the chart. To make this a professional chemical equation, we add state symbols. These tell us if the substance is a solid, a liquid, a gas, or an aqueous solution in water. We mark the iron and the iron oxide as solids and the hydrogen as a gas. In this specific reaction, the water is used in the form of steam, so we mark it with a G for gas rather than an L for liquid. This is our finished equation. We have moved from a broken skeletal draft to a representation that follows the law of conservation of mass. You've just used a professional framework to describe exactly how these specific chemicals interact. Now try it yourself. Use the same hit and trial method to balance the equation for magnesium, burning, and oxygen. Mastering this method is a core skill for any further study in chemistry and laboratory science.